Describing a JFET circuit, the following terms and parameters are important. So first of all, I will introduce those terms and then we will explain about those terms. First one is shorted gate drain current, then next is pinch off voltage, and then gate source cutoff voltage, and there are other three parameters: AC drain resistance, transconductance, and the amplification factor. The shorted gate drain current is denoted by IDSS, and the pinch off volt we denote by VP, and the gate source cutoff voltage is VGS for gate source. Now in order to denote the cutoff voltage, we will write down the off here. So this is denoted by VGS off, and the AC drain resistance is denoted by RD, R for resistance and D for drain, and the transconductance is denoted by GFS, and we denote amplification factor by the letter mu. Now we will explain about each of these terms and parameters. So let us consider a JFET, and this is an n-channel JFET, and this is a drain, gate and source terminals. So this is my gate, this is our drain and source. Now I am shorting the gate with source, and I am applying a potential between drain and source. So there is a battery. Yeah. Now, I have already said the gate and source is short circuited. Now, suppose we increase the VDS, the voltage in between drain and source is increased. Then let us show the characteristics of this JFET. This is the output characteristics: ID versus VDS. As VDS increases in step, the ID will start to rise sharply, and it rises and rises, and at some point ID become constant, and this voltage at which the drain current ID become constant is said to be pinch off voltage Vp. So pinch off voltage Vp is the minimum voltage, minimum VDS, minimum voltage between drain and source at which the current ID becomes a constant. The pinch off voltage Vp is defined. Okay. The corresponding current here, the corresponding drain current will be IDSS. This is for VGS is equal to 0 volt, when VGS is equal to 0. Okay, so what is IDSS? IDSS is the maximum drain current for a JFET. So this is the maximum drain current. After that, the drain current is not increasing. It stays constant at that value. So IDSS is the maximum drain current of the JFET, and it is defined by the condition VGS is equal to 0, VGS is equal to 0 voltage, and VDS is greater than VP. So IDSS is the maximum drain current with conditions VGS is equal to 0 volt and VDS is greater than pinch off voltage VP. So we have said what is IDSS. So VP is already explained and IDSS is explained. IDSS is the drain current with source short circuited to the gate, that is VGS is 0, and drain voltage equal to pinch off voltage, or drain voltage VDS greater than pinch off voltage. Okay. Now let us discuss about the gate source cutoff voltage VGS off. So let us draw the curve between ID and VGS. So I will show it here. So I have ID here and this is VGS. So already we have drawn a diagram here, VDS and ID against VDS. Now I am plotting the curve between ID and VGS. As the reverse gate voltage, that is the voltage applied here, as the reverse gate voltage is increased further, the cross-sectional area of the channel decreases. So ID will decrease. ID decrease and decrease further, and at some point this ID becomes 0. This voltage is said to be VGS off. So once again I am repeating, as the reverse gate source voltage is increased, the cross-sectional area of the channel decreases, and if the cross-sectional area of the channel decreases, the resistance increases and drain current ID decreases. And at some voltage VGS, the depletion layer extends completely across the channel and the channel is cut off. So ID will be equal to 0. The VGS at which ID is equal to 0 is said to be the VGS off. So the VGS at which drain current is 0 or channel is cut off is called gate source cutoff voltage, VGS off. Now a point to note is VGS off is always equal to VP minus VP, or the pinch off voltage VP will be always equal to VGS off. So if the VP of a device is 5 voltage, then VGS off will be equal to minus 5 voltage. Now let us discuss about the other terms. Now the other terms are drain resistance, transconductance and amplification factor. So first of all, what is the drain resistance RD? The drain resistance RD is defined by the equation RD is equal to delta VDS by delta ID at constant VGS. So it is the ratio of change in the drain source voltage to the change in the drain current at constant gate source voltage. Now next is the transconductance GFS, and this is defined by delta ID by delta VGS at constant VDS. So it is the ratio of the change in the drain current delta ID to the change in the gate source voltage delta VGS at constant VDS, or at constant drain source voltage VDS. So what will be the unit here? The unit will be here milliampere per volt, because the equation is current by voltage. Or now this GFS means this is the inverse of resistance, because we know that the resistance R is equal to V by I, and now here our equation for G is I by V. So the unit of resistance is ohm. So the unit of conductance will be MHO, mho. So this another unit is mho, MHO. That is the unit of transconductance. Now you may be familiar with the term transconductance. So I will explain it. Suppose you have a circuit, then you have some input voltage here. So this is my input voltage and some output current here. Then the transconductance means the transconductance is actually transfer plus conductance. Transfer plus conductance. That is an electrical parameter, electrical characteristics relating the current through the output of the device and voltage across the input of the device. So transconductance is an electrical parameter describing the relationship between the output current and the input voltage. Now we have one more parameter, and that is amplification parameter or amplification factor mu. Now it is defined by the equation mu is equal to delta VDS by delta VGS at constant drain current ID. So it is the ratio of the change in VDS to change in VGS, or output voltage to input voltage, we can say output to input. Always in amplification factor we take the gain of the amplifier as the output by input. Similarly here we have defined mu as the output by input, and output is output voltage delta VDS, and input is the delta VGS. So these are the parameters. Now if you consider the definitions of the drain resistance and GFS and mu, then you can relate all these three in a single equation. So I can write down delta VDS into ID by delta VGS into ID. So this ID and will get cancelled. Now this can be written as delta VDS by ID, sorry, not just ID, delta ID, I have to use delta ID into delta ID by delta VGS. So what is delta VDS by delta ID? Delta VDS by delta ID is RD. So this will be equal to RD into delta ID by delta VGS is GFS. So this is GFS, and this is amplification factor mu. So the amplification factor mu is equal to the product of the AC drain resistance and transconductance. So this is the relation connecting between the three parameters RD, mu and GFS. If you consider a BJT, then the output current IC and the input controlling parameter IB is related by the equation IC is equal to beta IB. Beta is a constant. So this is a linear relationship between input and output parameter. But for JFET, this type of linear relationship does not exist between the input and output quantities. And the relationship is ID is equal to IDSS into 1 minus VGS by VGS of whole square. Now VGS is equal to VP, so you can write down this as IDSS into 1 minus VGS by VP whole square. So this is the relationship between the various parameters. Now what is ID here? ID is the drain current. And what is IDSS? It is the drain current with source short circuited to gate, and VGS is the gate source voltage, and VGS off is the gate source cutoff voltage, and VP is the pinch off voltage. Now let us solve certain numerical questions. The first one is a JFET has following parameters. IDSS is equal to 32 milliampere, and VGS off is equal to minus 8 volt. VGS is equal to minus 4.5 volt. Find the value of drain current. So we are asked to find out ID. So what is the equation? The equation that we have to use is ID is equal to IDSS into 1 minus VGS by VGS off. Now that will be equal to IDS is 32 milliampere into 1 minus VGS is 4.5 volt and VGS off is 8.8 volt. So you have to substitute these values, and if you substitute these values you will get the current as 6.12 milliampere. So it's just direct numerical question. You have to substitute the values in the equation that we discussed. Now the second question is a JFET has drain current 5 milliampere. So this is ID and IDS is equal to 10 milliampere and VGS off is equal to minus 6 voltage. Find VGS and VP. Now readily you can write down VP is equal to minus VGS off, so that will be equal to 6 voltage. So VP is already solved. Now what is VGS? So how to get the value? We know that ID is equal to IDSS into 1 minus VGS by VGS of whole square. So this will be equal to, now you have to substitute the values. 5 milliampere is equal to 10 milliampere into 1 minus VGS, we have to find out VGS by VGS off is given minus 6 voltage square. So we have 5 is equal to 10 milliampere and milliampere can be get cancelled into 1 plus VGS by 6. Okay. So this will be equal to 5 by 10 is equal to 1 plus VGS by 6 whole square, or 1 plus VGS by 6 is equal to root of 5 by 10. So that will be 1 by 2. 1 by 2 root will be equal to 0.707. So 1 plus VGS by 6 will be equal to 0.707. Now you have to solve this, and if you substitute this and if you find out VGS, then VGS will be equal to minus 1.76 volt. Minus 1.76 volt. Okay. Now let us read next question. When a VGS of JFET, when VGS of a JFET changes from minus 3.1 volt to minus 3 volt, the drain current changes from 1 milliampere to 1.3 milliampere. What is the value of the transconductance? So what is the definition of transconductance? The transconductance is defined as delta ID by delta VGS. So what is delta ID? The drain current changes from 1 milliampere to 1.3 milliampere. So change will be 1.3 minus 1, that is equal to 0.3 milliampere, and VGS change is 0.1 volt. Okay. So if you substitute that values, then 0.3 milliampere by 0.1 volt. So that will be equal to 3 milliampere by volt. So 3 milliampere by volt. So this is the value of GFS.